Welcome back to Domain 1, Lesson 3, Algorithm Selection. The key to the Comptia AI Plus exam. You don't need to know how these algorithms work mathematically. You need to know when to use them. Today we'll be covering algorithm selection that tells you exactly which algorithm to pick based on the problem. Before we look at specific algorithms, you have to understand how algorithms are organized. Algorithms fall into categories based on the type of learning and the type of problem. For supervised learning, which is learning where the algorithm labels data or comes with a label that allows the model to accurately predict which label to apply, there are two types. One is classification, which predicts a category, and the regression predicts a number. For unsupervised learning, the main problem type is clustering, finding groups in data. The key insight for the exam is first you want to identify the problem type. Then pick an algorithm from the right category. For example, if the question is about predicting categories, you need a classification. For if you want to predict a category, for example, you're trying to predict a movie category, if you're asking the algorithm, is this going to be a horror film, a comedy, or an action film, you need an classification algorithm. If it's about finding groups with no label, which is basically just data, it doesn't have any categories, you don't know what genre movie it is, that would be regression. If it's about predicting numbers, you need a regression algorithm. Never pick a clustering algorithm for a classification problem. Never pick a regression algorithm for a clustering problem. Why? Because regression algorithm only deals with numbers. Clustering problems have no labels, so they are just natural data. First, step one, identify the problem type. Step two, pick algorithm from the matching category. If you're finding groups, think clustering. If you're finding categories, classification. If you are predicting numbers, regression. Let's start with the classification. We're going to dive into the classification algorithm. Classification is about predicting categories such as spam, no spam, fraud, or legitimate. or cat or dog, approved or denied. A classification algorithm would be used in an example if you're going to apply to a loan. You're going to be, the classification is going to put you in a category least likely to default on the loan or most likely to default on the loan, and that will determine if the bank approves you. There are 6 types of classification algorithms. 1. Logistic regression. 2. Decision tree. 3. Random forest. 4. What is called SVM, which is support vector machine. I'll explain that along the way. 5. Naive Bayes, and K, nearest neighbor. Number 1 is logistic regression. Despite having the word regression, this is considered classification. Logical regression predicts the probability that something belongs in a category. For example, it might be an action movie with comedy elements. The algorithm model, or the model will decide which category to place it in based upon the probability or the amount of comedy or the amount of sample size that has it labeled as a comedy or an action film. If the model outputs a number between 0 and 1s, because that's how computers communicate, we convert it to yes or no. If probability is above 0.5, predicts yes. If probability is below 0.5, predict no. It's best for binary classification, so use logical regression for binary classification, which is basically an answer between yes or no. Number 2, decision tree. A decision tree makes decisions through a series of yes or no questions. Think of it like a flow chart. Is age greater than 30? Yes. Is income greater than 50,000? No. Then we predict that they won't buy. The big advantage decision trees is they're easy to understand and explain. Number 3 is random forest. A random forest is basically many decision trees working together. Each tree makes a prediction. We'll say branch. Each branch makes a prediction. Then they all vote, and the majority wins. So, for example, branch 1 say spam. Branch 2 says spam. Branch 4 says not spam, and branch 3 3 out of 4 for 3 out of 4 decision trees say spam, so the random forest would have it labeled as spam. Random forests are more accurate than a single decision tree because they reduce overfitting. All right, so classification number 4. Support vector machine. SVM finds the best boundary lines between two categories. So imagine you have dots on a page. You have circles and you have squares. And SVM draws a line that separates the circles and squares with the maximum margin. So if you have data, it's especially useful when you have data with a lot of features. Number 5 is naive bias. It uses probability to make predictions. So basically, you're given a description, and the question is, what's the probability of each category? Naive bias is especially good for text classification, so spam filtering, sentiment analysis, and document categorization. On the exam, if you see a question about classifying text or emails, think naive bias. For example, if you're, let's use our spam filter. So if there is the word free in an email titles, it's 80, we decide that it's 80% chance that it's spam. If you see meeting in email, it's 90% chance not spam. It's not an email you want to miss. So you combine probabilities to make predictions. Number 6, K nearest neighbors. KNN. KNN is simple. Find the mean most similar example and see which categories they belong to. K nearest neighbors is a democratic way. So if house one has the category is cat, house two has the category is dog, and house three has the category is cat, the K nearest neighbor would vote that it be categorized as a cat due to two out of the three choosing cat. Next, that's it for those six classification. Next, we go back to regression algorithm. So remember, regression equals numbers. House prices, age, salary, any numerical data falls under regression. If the answer is a number, not a category, if you need regression. So house prices, age, salaries, temperatures, those are regression. And there are only two types of regression algorithms. One is linear regression, and the second is polynomial regression. So linear regression is it fits straight line through the data and finds the relationship between inputs and output. Example, as square footage increases, price increases. For example, if you have a 500 square foot house, it would cost less than a 750 square foot house. That would be considered linear regression. The line shows the relationship and lets you predict prices for new houses. Linear regression is the most widely used regression algorithm. Number 2, polynomial regression. Polynomial regression fits a curved line through your data. It can capture more complex relationships. So it captures more complex relationships than linear regression. So here's what you need to know for the exam. Classification predicts categories. Regression predicts numbers. If the output is a number, it's regression. If the output is a category, that's classification. That covers it for today's lesson. You can find this all-in-one study guide when we finish the lesson for domain 1. There are still 4 more domains left, but this domain 1 creates the building blocks for the rest of the sections. Thank you for tuning in.